Welcome to lesson 9-7. We're factoring those special cases that we saw earlier. So here we're looking at m squared minus 6m plus 9. So if we go back to our guess and check method, we know that our third term is a positive, so our signs are the same. We've got m squared there, which means m times m for both of our first terms in each of the binomials. And then we look to our middle term, our second term, and we see that's a minus. So again, we know both of those are going to be minus. Now, numbers that, when multiplied together, give us 9 and add up to 6, 3, and 3. And what you see here is that we have the same thing. So we can rewrite that as m minus 3 quantity squared. So guess and check works for this. The point is that you want to start picking up on those patterns. You want to start looking and saying, hey, I have a perfect square of 9. If I take the square root of that, which is 3, and double it, do I get that middle term? If so, then you know it's going to be that special case. Let's try another. So in this one, this is a kind of like a word problem. If you imagine you've got an area, okay, that is represented by that expression there, 16h squared plus 40h plus 25, and you know it's square inches. So if we know it's a perfect square, then we can kind of go hunting for those squares. And what's the square root of the first term? Well, that is 4h. And what's the square of the last term? That would be 5. Okay, and it's a positive. So now if you imagine, and if you want to check it back to make sure that it works, you can write it out. FOIL, first, outer, inner, and last. And when we see that, we notice that it is correct. So here we have a square minus a square number. Okay, remember how we got rid of how the outers and inners canceled each other out, and we got rid of that middle term, and now we can see that something happened there. So with knowing that our second term is canceled out, if we take the square root of both the first term and the last term, we can see here how a minus 4 times a plus 4, our outers and inners will cancel each other out, and we do get a squared minus 16. So again, it's all about recognizing those special cases and something has happened. One more example here. Now we've got our a value is greater than 1, okay? But it's still a perfect square. So we can take the square root of that and multiply it. And now we see that we get 9b squared minus 25 because the square root of 9b squared is 3b and the square root of 25 is 5. And now we have the difference of two squares. In our last example, we noticed that 5x squared is not a perfect square, is it? And 80 is not a perfect square either. However, I'm sensing a GCF of 5. If I factor out a 5, I'm now left with x squared minus 16, which is the difference of two perfect squares, right? So now I can factor it a little further. And again, we're going to have three terms here now. X minus 4 and x plus 4. So sometimes when you don't have the difference of two squares, look for a GCF and see what's going on. Again, please don't forget to do the post-video check. Ask if you've got questions, and I'll see you in class.